This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we support design engineers and make lightning protection easy. You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Aerospace Engineering Podcast. I'm your co-host, Dan Blewett. On today's show, got a bunch of great topics, a lot of really interesting EVTOL stuff back in the news cycle. We're going to start off with the GE9X, their record-breaking engine. Talk about some of the capabilities that they've demonstrated recently at the Dubai Air Show. We'll talk about some more Boeing 787 manufacturing issues. They're having some problems with their carbon fiber composites. More reporting by Seattle Times aerospace reporter Dominic Gates. We'll talk about one of his recent articles that looks like more trouble for Boeing. We'll talk about the Celera 500L, the very interesting sort of blimp-shaped laminar flow. Their big thing is, start that one over. We'll talk about the Celera 500L, which is Otto Aviation's creation that really rides the coattails of laminar flow, and their goal is to really reduce the cost of private jet travel, or whether it's air taxi, whatever their application might be. But their really unique aircraft, the 500L, is back in the news cycle today, and they've done a lot of flight testing, and they're ready to release some info about that. In our EVTOL segment, we'll talk about the CityHawk, which looks a lot more, again, like one of those sort of Blade Runner style air taxis of the future. This one with all the fans sort of tucked inside, which is a good safety step, but we'll see if that prototype has any realistic outlook in the future. We'll also talk about an eMagic aircraft prototype and some big news from Joby as they start talking about seriously the FAA certification process. So, Alan, let's start off quickly with the GE9X. This is a just gigantic, impressive GE turbine engine. So at the Dubai Air Show, they talked about just how powerful this is, but also how robust it is, ingesting lots of dust and sand that are, I guess, not typical of a certification effort. Is that true?
Right. Usually don't have dust ingestion as part of their cert effort. At least, they have a huge test facility in southern Ohio, in Peebles, Ohio, which I've been to a couple of times doing lightning tests on a variety of different power plants down there. But if you're selling airplanes in the Middle East, one of the big issues is sand and dust. Just like in the military, when the military aircraft were in the Middle East, they had big problems with sand and dust getting to the engines and starting to destroy equipment. So they've gone ahead and just done some really strenuous tests and just sucking in dust to see where it goes, because you can well imagine if it gets past seals or into places where there's lubrication, it just ends up grinding, destroying things. So it's a really interesting tactic by GE to try to address the concerns up front, because fixing an engine of that size can be really, really expensive. And you think that they're probably going to sell quite a number of larger transport aircraft to the Middle East. And so they're just being proactive, which is really kind of cool. You don't see a lot of proactive engineering tests like that. Mm-hmm.
So when they say dust, what do they actually mean? Because when I think of dust, I think of, wiping your cabinet in your house and you're like, gross. But is dust, does that mean sand? What does it exactly mean? I feel like it's a very vague term.
Yeah, it's going to be sand typically, or finer particles, because the finer the particle, the more places it can get into and cause more damage. The larger particles, we all know, are just erosive. So the inlet blades and all the sections where sand can get into or dust can get into, they're going to check for erosion. And that's why they're boroscoping, looking for that kind of damage inside the engine when they run these tests. The kicker, though, is, you always have some sort of erosion because the blades are hitting the little particles, and that's going to do some damage there. But you really, really, really don't want to get into rotating pieces, the bearings and that sort of thing. Sometimes the finer the particle, the more likely it can kind of find those small crevices to crawl into. And that's what you're really checking for, because you just destroy an engine that way.
Yeah. Well, I mean, so if an aircraft is just rolling down the runway, I mean, the jet engines are on. I mean, how are they not just sucking up every little piece of dust like a vacuum cleaner as they're just doing their daily rounds? They are. I mean,
But yeah, oh yeah, they are. Yeah, they are.
but how is that not a catastrophic thing? I mean, what's the difference here?
Well, it's just a matter of how well the engine can handle it. If you ever watched the little cyclones that develop in front of an engine, like if it's raining outside and you happen to be sitting where the engines are and the engines spool up, you kind of see those tornado cyclone events that happen in front of the engine. They're sucking in water, right? Not a lot of it there, but they can suck in debris from the runways. That's why you try to make sure that the areas are free of FOD, foreign object debris, right? Sand and dirt being one of them, because it can get sucked into the engine, particularly like on a 737, which engines are relatively low to the ground. With a 9X, the engines are going to be a little bit farther off the ground. But the thrust, like you were saying, Dan, is so massive, it's got to suck in a lot of air also that can pull things from the ground. And if you're in the Middle East or places where it's really sandy, what's the likelihood you're going to get all the sand off a runway or a taxiway after a dust storm? I think the answer is probably close to zero. You're really going to get it, all of it. And that's what can lead to premature wear and tear on an engine. And that's why they're checking it.
Mm-hmm. Okay. So it sounds like they're just doing their extra diligence, just trying to show that this can definitely handle pretty significant dust, even though GE engineered their own dust, which is interesting. The GE Research Center in New York, they made their own special dust for this this test. But yeah, okay. So it sounds like you're trying to get in front of it and just show off, hey, this is not only a record-breaking, gigantic, powerful engine, but also very robust. So makes sense.
Yeah, and GE has if you've ever been to the research center, which is not very far from us here, it's probably an hour away from our facility. They have basically a building full of really smart people to do work just like this across all their divisions. And then obviously in Evendale, Ohio, where the engines are manufactured, they're full of engineers that have a lot of experience on the kind of damage that they see from the field. So they can go back and recreate it at their test facility in Peebles. That's what's going on. So it's really fascinating, because you don't think you don't think airplane companies, engine companies are doing that kind of work, but they really are, because that's what separates them from everybody else.
Well, speaking of engines, the Boeing 787, the Dreamliner, is having more problems, and a memo update from late last month, Boeing has told the FAA that they found or carbon fiber contamination that's now at other major suppliers, not only in the wings, but also in the fuselage and tail. So, Alan, obviously, you know quite a lot about carbon fiber structures and this whole process. What's going on here? What's the core of this issue now with the 787?
Well, Mitsubishi found it, and Mitsubishi builds the wing for the 787. And as part of the construction process of making a piece of carbon fibers, you have these bags, basically vacuum bags, that apply pressure to the part. That's why you cook it out. And the epoxy cures. And they're finding that somewhere in the process, Mitsubishi realized that like a stringer on the inside of the wing hadn't adhered to the level they thought it should, probably in some quality testing that they're doing and sampling program that Mitsubishi set up. They were looking at numbers and realized they're seeing some sort of slight changes in the performance. And then everybody starts digging around to see what's going on, most likely, and they realize that there's some Teflon contamination. And once you realize you got Teflon contamination in a composite joint, you really got to be concerned, because the reason we use Teflon is that nothing sticks to it. So if you do get Teflon in between two pieces of carbon fiber you're trying to bond together, they're not going to stick as well as if they were clean. And the problem with Teflon is that once it gets on a surface, it's really, really difficult to get off a surface without basically abrading it off or really corrosively, chemically trying to remove it. So Mitsubishi finds this problem, tells Boeing about it. Somebody at Boeing, I'm sure a lot of people at Boeing had the same red flag I had when I first read this, well, if Mitsubishi has a problem with the vacuum bag, everybody has it around the world. And we need to start looking to see how bad it is. And, of course, they start finding it in other places. So it's not just a one location, one part problem. And now it becomes kind of a global problem. Then when you have composite structures glued together, they're not going to stick as well. And they're finding that depending on where the part was built, what part of the world it is, some of those joints aren't performing to the level they should. So you can well imagine the engineers at Boeing just basically pulling their hair out and going, what is going on with this program right now? Why can't we get a 6-month or a year-long run of no problems? What is this? And Dan, can you imagine? Basically, one of the most fundamental pieces of making a piece of carbon fiber, which is the vacuum bag, is now contaminated. And now you got to go back and figure out what to do about it after the fact. That's really hard. Really, really hard. And it sounds like the engineers have been working on testing and looking at those joints. And it seems like some of the joints are pretty strong, like they're within the engineering allowables. Some of them aren't. What do you do? Yeah,
it seems like a really awful problem. Really awful. I mean, what doesn't Teflon ruin nowadays, right? No, Teflon was the miracle cure back in the, 40s, 50s, something like that, 60s when it was developed, and developed by accident, I'm pretty sure. And here it is, still screwing life up. The miracle to disaster curve of modern inventions, most specifically plastics. But
yeah, well, it's good at what it does, but that's one of the things about airplane manufacturing lines is you can't have Teflon. Like Teflon sprays for lubrication, films, anything of the sort, because it does leave like a residue, particularly on your fingers. I don't know why I say so much on your fingers, but I've seen this thing happen. Someone will get some Teflon on the manufacturing line that doesn't belong there, touch the airplane, and then when they try to paint it, the paint will not stick there. And there's really not much you can do to get that off. So you can really ruin an airplane paint job very quickly. And so Teflon has been essentially banned in the factory for most things. It's odd that the vacuum bags have slipped through that. And then did you see the second part too, Dan, which is the titanium fittings, that they had basically an incorrect alloy in some really major structural pieces inside the fuselage. That's not good.
Is this an extension of what we discussed maybe last year, that Boeing over time has outsourced more and more of their fabrication to other suppliers that they used to back in the golden ages do a lot more of it in-house? Is this a problem of that sort, or is it just inevitable the way the world is nowadays?
Well, I was trying to read between the lines in Dominic's article, and some of the problems seem to be located at Leonardo, which is a major subcontractor to Boeing on the 787. The titanium pieces were an issue. They're also having shimming issues that seem to be coming from Leonardo on composite to composite parts. They're not lining up like they should, and they're not getting shimmed properly, and they don't have a quality system over top of the manufacturing system there to inspect the parts, make sure they're right. So now they got titanium alloy problems, and they have shimming problems from one supplier. They've got this Mitsubishi wing issue with the Teflon bags, which then I think it went everywhere. That was one of the big things about the 787 when they did all the design for it and outsourced. Pretty much all the major structures were outsourced around the world, not just in the U.S., just all over the place, to reduce the amount of basically workers and time that Boeing would spend on the aircraft. They were going to be an assembler, not a creator sort of thing. That was the goal. But that seems to have backfired on some level, that they ended up buying some of the divisions, like the division in South Carolina was not Boeing originally. They actually bought that because it was a subcontractor that wasn't performing up to spec, and so Boeing just came in and basically took over that operations, and Boeing has done that in other situations. So the question is sort of twofold here, Dan. One is this: is the major subcontractor quote-unquote partnership a viable business and engineering effort? I think that's one. And two, are these large composite fuselage structures, which I think is where they're having primarily the problem on shimming, are they realizable? Can you do it? Can you really? Theoretically, you can do it, but in practice, because of the size and the tight tolerances that are involved, is it truly reliably, predictably built? Based on 787, I would say not looking so well. And one of the interesting things that's been bebopping around on some of the discussion forums is the Airbus A350 and some of the composites that Airbus has been working on. Do they have similar issues, or is it only a Boeing issue? I'm not sure we're ever going to know the answer to that one. But if it's a universal composite big size problem, it's better to find it out now. And it makes you wonder if Boeing will build another composite fuselage again.
Yeah, might just not be worth the trouble. Yeah,
might not be worth it. Yeah.
Well, speaking of interesting fuselages, let's talk about the Celera 500L, which is a product of Otto Aviation. And of course, we talked about this in the quirky design and whether or not people would accept this as a business jet alternative, because people that buy business jets are fancy people, if you want to put it that way. They're high-powered folk who've got important places to be. And even though getting there quickly is important, they also care about how it looks. And do I get the panache of, having a business jet? If you have a business jet, might as well have a nice, cool, looking business jet. So anyway, we had a lot of discussion about the aesthetics, so that even if this is like a beautiful, amazing aerodynamic, fuel-saving design, would people actually accept this and say, yeah, I want this sort of blimp-looking, aircraft that's going to save me money, almost like as if it's the minivan of, business jets. So a lot of discussion on that. And again, it's certainly got its merits if some of their claims pay off. And let me go back through some of the Celera 500L's claims. They say it's going to get 18 to 25 miles per gallon as opposed to 2 to 3 for a comparable business jet. This would reduce their hourly operating cost to $328 per hour versus $2,100. That's about six times cheaper, with a maximum range of 4,500 miles versus 2,100 miles, because it's going to be able to cruise that much easier, burning less fuel because of the laminar flow that the design and the aerodynamics boast. So, Alan, a lot of big claims about this just being a really economical jet. The really economical prop-pushed aircraft. And they've done 55 flight tests now, and they've gotten some good data. So what were some of your takeaways from their press release and the video showing the Celera 500L in the skies?
Well, it's like any aircraft that's in that early stage of development, where they're trying to get some numbers and to validate what the paper calculations say. And it's good that they've gone off and done that, because no one's going to move forward on a project in which they can't verify the speed numbers, the efficiency numbers. So that's all good. I think where they're at now is a really critical piece for them. If the aircraft has momentum and there is a marketplace for it, evidently, with that lower operating cost, you would think that would be a very viable product. And because it has a very large cabin, those are two workable pieces. And I think that would make it a very popular aircraft. The question is whether you get funding to get to the next stage and drive it to a completion in terms of certification. They may be able to do that. The press release is part of that package where you're looking for investors to come in. And you know, Dan, we're in this kind of weird SPAC world at the moment where hundreds of billions of dollars can be available to develop an airplane. So if they get the right backers for it, there could be a viable aircraft coming out the end. But again, when they get into those negotiations, they're going to need data before they get $300 million, $400 million to go build this aircraft, which is probably what they're going to need. they're going to need to be able to show their numbers and to validate what they're talking about. And obviously, they didn't take the aircraft up to the final flight altitude. I think it was the maximum flight's like 15,000 feet or so, which is typical for early flight tests kind of things. But when you start to project those out into some really high speeds and really high altitudes, you got to be able to show your work and show you can get that done. So cool technology, some really interesting results. Let's see if they can drive the program forward.
Well, Alan, so reading this article, there's a bunch of them, obviously. So there was a big press release, and this is an interesting, story throughout aviation. But article on the drive.com talking about the Celera's flight test results didn't give a lot of data. There are quotes from the company and all that, but they said, hey, we're on track to meet these claims that we've made. But they didn't really give any much data to back that up. They talked about being able to visualize through infrared some of the laminar flow, but they really didn't give any specifics about what they found on these flight tests. Is that typical, or are they maybe just keeping that close to the vest, or where is that data? What did they find?
I'm sure they have a ton of flight test data. It's rare that you see that flight test data talked about publicly. If you think about what's happened with Joby, which is now in the $1 billion field in terms of investment money, you've seen very little from them in terms of flight test performance. You just don't tend to see it. I remember years ago on the Beech Starship, when Rutan was trying to sell Beech an airplane, there were still bad feelings about that years after that, but the Rutan group had given them some numbers, some flight test performance numbers that Beech used to decide to take on that project. And when they got to building the final airplane, the numbers didn't align with that early flight test stuff. So it's sort of buyer beware here a little bit. And I think that's because those numbers are sort of first cut, perfect airplane, not final design. A lot of different things are going to happen to the aircraft before it gets to the final stages and what it looks like there. So you got to take this with a little bit of a grain of salt. I think the one thing that the 500L can rest on is the work that Honda did on the Honda jet. Because the Honda jet is a lot of laminar flow, and the numbers there are pretty good. I think they sort of backed up what they were saying early on in terms of getting laminar flow. But they've been very, very, very sort of anal towards making sure their airplane is clean, like really clean in the front. And Celera is going to do something similar. So it isn't like they don't have any something to work off or someone has actually taken this path and been successful with it. But it's been Honda. And Honda is a multi-billion-dollar corporation. So they have the wherewithal to spend the money. Otto's going to have to do something very similar. The problem is, where's that money going to come from? And what are they going to show those investors? Great question.
All right, moving on to our EVTOL segment today. We got two interesting aircraft designs we're going to get Alan's take on. So the first one, and this one is very much the going after the Blade Runner market, right, or the Fifth Element market. Take your pick of your weird sci-fi movies. I watched The Fifth Element the other day. It's one of my favorites. But this Israeli company, Urban Aeronautics, has a design called the CityHawk. And it's interesting. It's got basically a huge duct front and rear, so like where the trunk would be, where the engine would be in a car. And then in the center section, you get your one or two seats in the middle. And these ducts, or these fans, are completely ducted in and sort of tied into the body of the vehicle. And so, don't have the propellers exposed, which seems like it could bump into stuff a little bit almost and still be okay, which obviously is what you're going to need if this would ever be like a Fifth Element kind of thing where you just putter around, get in a car chase, get shot at by the cops, go get your Chinese food, save the world, what have you. But it's an interesting design. Alan, does this one have any chance to get to market? What's your take on what Urban Aeronautics has going on here?
Well, it's based on an earlier military design that the Israeli company has come up with. And so this aircraft is like a derivative of something they've already shown in a working form, which is really fascinating because I think there is an advantage to being smaller. I think there is. Energy efficiency is going to go down, you would think. It's going to require more battery power or engine power, whatever they're going to use to make this thing fly, it's not as efficient as something with a wing on it. So it's going to make shorter flights. But as we talked about before, I think one of the key pieces here about being mobile is being able to land in smaller places. If you're landing airport to airport, it doesn't really matter too much. But if you're going to land someplace in a more urban environment or suburban environment, size matters there. And if it's too big to land, then you're pretty much going to airport again. This particular design has thought about that a little bit. And they could squeak into smaller spaces, which may open up more markets for them. I think, Dan, as we go back, talk about like the GE9X dust testing, I think the same thing may happen here, though. When you're trying to put an aircraft down in a small space, things like dust and dirt and debris and all that nonsense start to play into it. So you're probably not going to land it in a place on a downtown Washington, D.C. street, because you may suck in a bunch of junk, right? Or an airport, you're not going to do that. And there's... yeah, you surely don't want to clean that out. Yes, that would make quite a mess. But it is, I think what you're seeing right now is a lot of different angles on the similar problem of how can we move people around more efficiently? Is an aircraft like a Joby the right answer, or an aircraft like pick any of the other ones, right? So everybody's their own special flavor on it, and the marketplace has yet to have an input into it besides investors. The marketplace, like people like you and me, not that we're ever going to afford to be able to fly on one of those things, hasn't been involved at all. So there's still a lot of question marks as to where this goes. And you're going to have to find out, right? But the question is, are you willing to spend a couple $100 million to find out? That's the difficult part.
Well, speaking of pioneering designs, Thomas Senkel, who's a German aircraft developer, he has got a new design. And of course, you would maybe know him from his first, the world's first electric multi-copter flight in 2011 that he manned, basically sitting atop a Bosu ball or a Swiss ball, whatever you want to call them, these exercise stability balls, and then just strapped to what looks like about 12 rotating propellers all around him. It's a really remarkable photo, but clearly he has got the guts to put his money where his mouth is when it comes to, taking flight. So anyway, he has a new design. It's a tandem wing configuration. It looks kind of like a fighter jet with a bunch of propellers on both sides. And Alan, what do you think of this new creation from Mr. Senkel, who again has we've got so many people throwing just computer design prototypes in the mix, but we know that he means business when it comes to getting up in the air, because he's been shown 10 years ago to the willingness to do it himself. Yeah,
and I think that's some of that part of the adventurous spirit of real airplane designers, the guys that actually go out and design it and build it. Right, that's still alive, and I think that's a good thing. Now, again, it gets down to, does the design have legs? Can it be manufactured? Is it safe to go fly? Does it have all the features it needs? Does it have enough battery power to stay aloft? All those kind of interesting pieces are yet to be determined. But the way you do that is you start small, and then you get bigger over time. And that's not very much different than what like the Wright brothers did. And I think what you're seeing here is just sort of a reemergence of that sort of pioneer spirit that went on over 100 years ago by a lot of different aircraft manufacturers and designers at the time, is that they're going to go out and make something, build it. Not only draw and conceive of it, but actually going to go out and build it in a sort of very fundamental elementary form and show that it works. That gets to your next stage of, once you have something that shows that it works, kind of like the Celera, then I can go out and start looking for some money and prove it out and get it to the next stage, which is maybe a viable product, and see where it goes. And as we've seen so many times recently, there's been a lot of news articles about EVTOLs that are just on paper, and you're just like, there's just no way that thing's going to work. But when you see somebody sitting in an airplane or an aircraft they've built themselves and lifting off the ground, it puts some sort of something behind it that gives you a feeling like, oh, maybe that concept would work. Maybe you could expand upon it. Maybe you could make it so the system is reliable and all those little features, because the volocopter, which is derived out of some of these guys' work, is a viable thing. You can question about how much marketplace it has, but it's still it's going to be a very viable product. So all these things sort of develop over time. And does it happen in 2 or 3 years? Typically not. It tends to happen in the 10 to 15 year time frame, from sort of first conception, first original model, to certified product. It's a long cycle.
Yeah. So their creation, the eMagic 1, and I, like you said, you can appreciate about the team there that they said they wanted to have a functional prototype when they went public, and they have. So, they've shown the eMagic taking off conventionally, but then, they talked about the characteristics of the tandem wing design and how it's apparently really good. Like it won't stall. And then what specific aerodynamic advantages do you see this design having?
Probably better performance in slow flight. That's probably where, and the handling characteristics are very docile. Because you don't want a fighter jet type aircraft in the EVTOL market necessarily, because of the flight characteristics of it, right? Or you have to have a bunch of computers to make it fly, and it's very unstable, and so there's awkward phases of flight. You can get into accidents. It's very similar to what Beta is doing up in Vermont in terms of the aircraft design. Very docile aircraft to go fly. I know Joby talked about this in their presentation over the last week or so. They had an hour-long presentation. They were talking about their aircraft. If it lost power, what would happen? And their contention is it can glide to the ground, right? So everybody's trying to show that it has very docile handling performance. That means aerodynamically, you got to do a couple of things, right? You can't. You got you got to design it a certain way such that it doesn't overreact, or stall, or do all those kind of funny things that when these aircraft are going to operate at relatively low speeds, especially as you get close to the ground and get into hover mode, you can't have the aircraft roll over like a single engine Cessna would do at low speeds. It can't do that. So it's got to have a really unique wing and tail design, and a canard can also help with that because it's very docile around slow speeds. So just a lot of different, I would say, older aircraft designs, sort of like the kit building phase back in the 1970s and 80s. A lot of airplanes very similar to that.
All right, so last on the docket today is Joby, and there's a lot in the news cycle right now about them being the first to receive their FAA certification. So they're on track, that they say, to get to certification by 2023, which is only, depending on where in 2023, only 14 months off. It was the beginning of the year. Alan, so where are they right now in the certification push, and what are they talking about when they're getting so much attention in the news cycle about certification?
What Joby said on their investor presentation the other day was they have their issue paper from the FAA, so they know what their type basis is, all the rules they're going to have to go show compliance with. They have some certification plans in process. It sounds like you're talking about the beginning of 2022 before some of those cert plans will actually make their way over to the FAA, and then the real negotiations start on what's going to be done to show compliance. It also sounds like they're in the middle of building a first conforming prototype that would put them typically at that point in a standard program. You're probably 2 to 3 years away from certification. You're somewhere in there. It seems like they're a little behind on the certification plans, in my opinion, because there's so much work to do and so much testing to be done and flight tests to be done. They're probably, what they were saying on the investor call was that they would be done at the end of 2023. And I thought, well, in airplane talk, that means December 31st, 2023, because they want to enter service in 2024, early 2024, and they like to get their production certificate. So those things all jive, but do they have the horsepower to do it that quickly? That's a great question, because I don't know. I didn't get a really good feeling on that. It's like, do we have all the people in place, and assuming that there's no problems, and there's going to be a problem or 2 or 5 or 10 that happen during the flight test program or production cycle or all the other variable things that are happening that, there's just so many unknowns. That's why aircraft programs really tend to go much longer than usually. There's a 5-year window of when you apply for a type certificate to when you should finish it. Otherwise, they bump you with the next set of regulations the FAA does.
Yeah, I mean, just the way you've talked about it throughout our time on this podcast is it seems like these announcements are almost like a soldier announcing to the world that he's gonna become a Navy SEAL or a Green Beret. It's like, you mean you're gonna try, right? Like, because most people that go try come back a failure. Like, they don't make it, either, whether it's not because they gave up or because, well, a lot of them give up, but it could be they gave up, they got hurt, they couldn't pass a test. Like, there's a lot of reasons that people say, I'm going to be a Navy SEAL, for example, and no matter their declaration, they don't make it. It's really just the idea that you're going to try to head up that mountain. And so, I mean, is that kind of a decent analogy for this? Like, they can probably get there eventually, but the question is how many obstacles and hurdles and extensions they need, and then does that burn up all their cash?
That's the game. That's the risk, right? And I think the analogy sort of plays out. There's, if you can imagine, I think right now they say they have 1,000 employees. So you have 1,000 people going in roughly 1,000 directions every day, trying to meet one goal. And if some of them get off track, some of them leave, retire. You can just, even on the people side, it's such a huge problem. Just managing all that and to keep everything going is so hard. And the one that sticks in my head the most, probably because I thought they had the best chance from an airplane design standpoint, but yet couldn't make it to the finish line in a sense, it was Eclipse. And they had plenty of funding to go make this little twin-engine jet. Problem was the motors didn't work like they thought they were going to work, and then it just sort of drug on. And if Joby runs into a similar problem with electric motors or the high voltage cabling or the connectors or flight controls or a million different things, they're going to be in that same boat where they're going to get shoved to the right and the cost of the airplane is going to go up. And then how does that play out? And you've got people training to be pilots, and do they have to be retrained? Do you have to go pull them back into, right? So even like the 737 discussion about training of pilots, and Joby's going to go through that same thing. There's just so many pieces that are all tied together in this really unique chain of events that has to happen. Invariably, some of those links break, and you got to slow down and put it back together. So 2023, I think, could be aggressive. 2025, probably more realistic, but they're driving really hard. It's clear. I mean, they have very capable, from just watching some of the presentations and knowing the people that are working that project, they have a lot of talented people on that project at the moment. So they have a really good shot to do it. It's just making it all happen.
Yeah, well, it'll be interesting to see the climate of things in about, like you said, about a year, maybe 18 months, and see how close people really are and what companies are left still viable and fighting, because a lot of these prototypes, even now, looking back 3, 4, 5 months, there's a lot of prototypes that got one press release that they probably paid for about a new design, and then not a peep since then, right? Yeah, so a lot of these are going to they're going to die quietly, and the viable ones are going to keep charging, like you said. But that's going to do it for this week's episode of the Struck Aerospace Engineering Podcast. Thanks so much for listening. Be sure to subscribe on iTunes, Spotify, Stitcher, YouTube, wherever you're listening or watching. And we will see you here next week on Struck. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.